Hi, my name's Oliver Carson, and if you want to learn about Unity ECS, you're in the right place. So this video is the first couple of sections to the course Unity Dots Fundamentals. And that's a course which I've just released onto Udemy. Now, in it, we cover how to make a full game in ECS, and I made that because there wasn't many resources for that when I was learning ECS, so I thought I'd be proactive and make one myself. I'll include a link below to the course on Udemy, and I'll try and keep that updated with the best possible price you can get it for. So I hope you enjoy the following videos and you really get something out of them. Hi, my name's Oliver Carson, and this course is Unity Dots Fundamentals. And in this course, we're going to learn how to make a full game with Unity ECS and Dots Physics. Now, when I was learning how to use the Unity Entity Component System, I couldn't find many good video resources, and I couldn't find much information on how to make a full game with Unity ECS. So I thought I'd be proactive and create a video guide for everyone out there to learn from. In this course, we're going to learn how to make a simple maze game, and I hope you get a lot out of it because it's been a lot of fun to make. So before we begin, we're going to learn a couple of basic ECS concepts. So firstly, what even is ECS? So ECS isn't actually a new concept, but the implementation Unity are working on is still quite new as of time of recording, and it's still in preview at time of recording, but it's starting to get a lot more robust and its functionality is becoming a lot more concrete. So now's a really good time to learn it. So why would you want to learn ECS? Well, ECS helps you write maintainable multi-threaded code, and with today's CPUs becoming more and more core heavy, you'll get the best utilization of, say, 8-core processors. And even when you're working on things like mobile CPUs nowadays come with quad-core processors. And when you're writing mobile games, you need all of the speed and performance that you can get. So one of the core things that separates ECS from traditional mono behaviors in Unity is data and logic are separated. And this allows Unity to perform a number of things in the background to speed up your games. And more importantly, this helps to reduce dependencies. It's worth noting that ECS is just one part of Unity's big push for their DOTS data-oriented tech stack. We'll look into the DOTS physics and the hybrid rendering, and there'll be more DOTS packages coming out of Unity in the very near future. So firstly, you might ask yourself, what is the E part of ECS? What's an entity? Well, entities are our things. You can think of them like a game object, but they are different from a game object in a number of ways, and they're not interchangeable. So when we think about game objects are made out of various components, but those components are mono behaviors, and mono behaviors contain both data and logic. And game objects always have a transform, so they always have a position, a scale, and a rotation. They exist in a scene, and in general, mono behaviors are kind of geared towards single core operations. Whereas if we have a look at entities in ECS, entities contain ECS components, and ECS components only store data. It's worth noting that an entity doesn't necessarily have to have a position or rotation or scale in the world, but if required, we can add those as components to an entity. And entities exist in something called an ECS world rather than a scene. entities are also built for multiple threads by default. Now, there is stuff you will need to perform on the main thread, but in general, the ECS entities make it easier for you to write multi-threaded code. So now we've talked about entities, but what's the C part of ECS? What's a component? Well, as we touched on previously, components are where we store our data and only our data. So components don't have any logic on them. And components, to exist at all, need to be stored on an entity. Unlike mono behaviors, there's a number of restrictions on the data types we can use on components. So in general, they need to be blittable or primitive types. But there are some workarounds that Unity provide for things like strings, for example. So components aren't just for data storage though. They're also used to define our entities. So our entities are defined by attaching, modifying, and removing components. So it's really important that you think of components as a way to define the logic that's run on an entity. So let's have a little look at a component. So you can see on the component, firstly, we're using the unity.entities namespace. We're also using unity.mathematics, but we'll go into those later. So our component is not a class, but rather a struct, and it implements iComponent data. So our movable component here has a public float and a public float 3. And these are blittable types. You'll also note that our component here has a generate authoring component tag, and we'll get into what that does later. So finally, what's the S part of ECS? What's a system? Well, systems perform logic, but they don't store any data. So in the same way that logic doesn't run in a component, data doesn't belong in a system. One of the main uses of a system is to change the data stored on an entity's components, but that's not all they can do. So systems can also modify what components live on an entity and also create and destroy entities. So all of your logic is happening in systems. The main tool that systems have to perform this logic is something called a query. And a query will help you find specific entities with specific sets of components. So for example, if you wanted to find all of the entities that exist in the world that have a player component, you could create a query to perform that operation for you. So it's worth noting that systems can run both single and multi-threaded code. And there are times where you want to write things multi-threaded, but there are also times where you will want to write systems that run single-threaded. And we will go into that, so don't worry too much about it for now. So we're going to have a quick look at this example of a system. So again, we're using a whole bunch of different things here. So we've got unity.entities, most importantly, and our systems are classes, unlike the components, which are structs. And our systems inherit from something called system base that lives in Unity entities. And we've got, like a mono behavior, we have something called onUpdate, and this will run every frame. Within our onUpdate, we've got something called an entities for each. And within that entities for each, we're defining what's called a query. And queries are how we perform most of our logic in systems. And the query here is trying to find all entities in the world that have a spawner, a translation, and a rotation. And then we're performing various operations on that data. It won't be very long before we start writing our own systems. So this will become clear within time. So before we get started, we need to set up Unity to use ECS. So we'll need to get the latest stable version of Unity. We'll need to get the entities package, the hybrid rendering package, and the Unity physics package. Now, depending on when you're watching this, these will either be in or out of the preview packages in your package manager. So be sure that you have preview packages enabled in your package manager. And if you've not used the package manager before, don't worry because we're going to go over it. So I'm just going to create a new Unity project and I'm going to call it dots.man. Okay, so you'll see something like this and you'll want to go to Window, Package Manager. We'll need a few packages. So firstly, if we go to Advanced, and we need to make sure Show Preview Packages is enabled. Let's do that. And we're just looking for entities. So we're going to take the entities package here. We'll also need the hybrid rendering package. So we've got hybrid renderer here. And finally, we'll need the physics package. Well, we're going to be using Unity Physics here. So let's install that. Once that's installed, I want you to import the package file that I uploaded. So if you go to Assets, Import Package, Custom Package. And there should be a file called dotsman.art.assets.unity package you can just download and import into your project. So that's just going to have some helpful stuff. Okay, so once that's imported, you should have a 3D folder with a bunch of things in it, and a prefabs folder with a level chunks folder. That should just have a couple of things in there for later on. Okay, so now we're all set up. We're just going to spend a little bit of time going over the game that we're going to make, and then we're going to get started. So let's go over the game we're going to make. It's a game that's called Dotsman. And Dotsman is going to be a classic arcade maze game where you kind of collect dots, avoid ghosts, pick up power pellets, that kind of a thing. And for that, we're going to need some kind of a system to move things. So we'll need a movement system. We'll need to handle physics and collision handling, and we'll need something to manage the game state. And obviously, we're going to want all kinds of like gameplay features. So we're going to want different levels in there. It'd be nice if we could have some animation, some audio, and some basic UI. So these are the things we're going to cover. We're going to cover how to get all of this working in an ECS environment. So let's get started, and we're going to make basic movement with ECS. So what we'll learn in this session is we're going to learn how to create components with iComponent data. We're going to learn what a tag is and how to use them. We'll learn a little bit about authoring components, what they are. We'll learn how to create systems with system base, and we'll also learn a little bit about entity iterations with entities.forEach, like what a query is. We'll just learn a little bit about systems. So let's begin. Okay, so right off the bat, I'm going to want you to go to Assets and create a folder, and we're going to call that folder Scripts. And within Scripts, we're going to create a new folder called Components. And we'll also create another folder called Systems. Now I'm going to show you how to make a component first. So if we go to Components and we right click, we go to Create, and we go to ECS. You see we've got Runtime Component Type, Authoring Component Type, and System. We're going to want to create a Runtime Component Type. And we're going to call that Movable. And this is going to be the component that we attach to an entity to mark it as something that moves. Let's double click on that. Okay, so when we generate a component using the Unity editor dropdown, this is what we get. We get a public struct movable, and it's using the iComponent data interface here. So that's kind of done most of the work already. Unity has been nice enough to add like a little micro tutorial in here for for anyone who hasn't used components before. So let's have a look at what they've got to say. Add fields to your component here. Remember that a component itself is for storing data and doesn't do anything. Like we went over before, it's only for data and not logic. To act on the data within this component, you need a system. Data in a component must be blittable, which means a component can only contain fields which are primitive types or other blittable structs. They cannot contain references to classes. So, like we went over before, you can only add things like numbers, like base types, like anything in mathematics will kind of go in. So yeah, we can't just create our own class which has a data structure and then add it into our component. We have to use like the base types. And below it, it says, you should focus on the data structure that makes the most sense for runtime use here. Authoring components will be used for authoring the data in the editor. This will become clear in a second. So if we delete this, and we're going to add some data into our component. So we'll add a public float speed, and this will be the maximum speed of our movable component. And we'll add a public float 3, and that's going to be called direction. As we briefly touched on before, float 3 lives in the unity.mathematics namespace, and that's optimized for burst, which is Unity's like low-level compiling technology, which makes things really fast. And obviously, it's built for jobs as well. So you can think of this like a vector 3, but it's not a vector 3. It needs to be a float 3. I want to use this with burst. Now we've made our component. We've just got some basic data in it. Okay, now that's all sorted. Let's just save that. So now we're in Unity. You can see we've got our component here. So let's try adding a game object. I'll add like a little cube in here. Let's see what happens when we drag and drop the movable component onto our game object. So it says con add script behavior movable. This script needs to derive from mono behavior. So when we create things in the entity component system, we're still making stuff here in the Unity editor. And to create stuff that the Unity editor can use, we need to generate what's called an authoring component. An authoring component is like, it tells how a mono behavior should kind of convert itself. And Unity's added some useful code to kind of negate that process. By default, we have this serializable tag. We don't really need this at the moment. We're going to change this tag to say generate authoring component. And what this is going to do, it's just going to create an authoring component that we can add to a game object that will say, you can attach me to a game object. So now we're back in our scene and we've got our cube. Let's try dragging movable onto our cube now. As you can see, that's added now, and it's exposed the speed and direction in our eye component. Now, that's not doing anything at the moment. For this to do anything, we'll need to add a system. Let's go to our systems, and we'll create ECS system, and we're going to call this Movable System. When you create a system at the moment using the Unity dropdown, it uses old ECS code that you shouldn't really use. Nevertheless, it is relatively useful to read through this stuff. For now, we're just going to delete all of it. We don't need any of this. And I don't like this either, so I'm going to delete this. So what are we going to do? Well, we're making a system, and all systems need to use system base. Now, you can see like some red lines here, so Movable System does not implement inherited abstract member system-based on update. So we need an on update to run our logic. So let's just alt enter there and just generate that. So in our system, we're going to find everything that's movable, and then we're going to modify its position based on the parameters. So to do that, we're going to use entities.forEach. And what this will do is we'll give it a query of things that we want to find. And this will find the components we want, and we can perform operations on them. So we just use two kind of brackets here, and then the syntax is a little bit confusing at first, but you get used to it. Within that, we're going to create another two, and we're going to create a reference using ref to movable, which is our component, and we're going to assign that to mov. And then we're going to use lambda here and some curly braces, and that's where our logic's going to be. All of our logic will be within this kind of lambda statement. Finally, we're going to do dot schedule, and this is going to tell our entities.forEach loop to be run in a job. So there's a lot to take in there. So we'll just go over these things one thing at a time. So we've got our mov, our movable component in here, so we can have a look inside of it. So we've got mov dot speed and direction. Obviously we can assign to them now, or we can read from them, but we've got nothing to assign or read to. Now, when we want to change the direction of a entity or change the position or the rotation, we need to get a reference to that entity's position, rotation, scale, whatever. And to do that, we use the unity.transforms namespace, and there is a component that's called translation, and this deals with your entity's position. So we'll get the translation, and while we're here, we'll get the rotation. Just ref rotation, and we'll call that rot. We need to modify the translation of our entity, so we'll do translation dot value, and if you have a look at value, it's a float 3, and we're going to add to that mov dot speed times mov dot direction. When you're making this in a mono behavior, you'd normally use the delta time to make this operation frame rate independent, and there's nothing different here. So to get delta time, we're going to go outside of our entities.forEach for a bit, and we're going to create a float dt, and it's going to be time.delta time. We need to perform this operation outside of our loop, sadly. And if we go back to our thing here, we'll just times that by dt. If we have a look at our cube, we'll just fold the collider and all of the other things for now. I'll set our speed to 1. Let's put it high. We'll set it to 10, and we'll set our direction to go 1 on the z-axis. So what's going to happen when we press play on this? Let's have a look. The observant of you will be noticing that nothing is happening. Now, the reason it's not moving is because this is a game object and not an entity. So how do we change that? Well, the current technique you would use to do that is you go to add component, and then if you type in entity, you'll see there's a convert to entity script. that you can just kind of add on. There's something here called conversion mode. In general, you're going to want this on convert and destroy. But there are edge cases for convert and inject, but let's not worry about that for now. One thing at a time. Let's try running our game now. You can see the cube's moving now as an entity. And you'll also notice that in the hierarchy, we can't see the game object anymore. That's because the game object doesn't exist anymore. We've just got an entity. So before we move on, if we quickly go to Window, and then we go to Analysis, you'll see there's something here called the Entity Debugger. So let's dock that to the left here and run our program. Now you'll see in the Entity Debugger, if we just expand this, we've got two entities in the, at the moment here. We've got one called World Time, which has a bunch of stuff. We've also got our cube. Now, we've got something here on the right here called Chunk Utilization. And this has all of the components which our entity cube contains. And if you have a look here, you can see it has the movable component. Also got a physics collider, a render mesh, a rotation, a translation. It's got quite a lot of different things. And also, if we have a look on the right here in our inspector, you can see how we've got the cube. We can see how our movable is here with the speed of 10 that we set, and the direction is set to 1 here, so set to forward. But we can also kind of look at all of the other things it's got. Now these are things that we didn't add, but the convert to entity script did for us. So if we have a look at our cube, you'll see it has a box collider, a renderer, and a mesh filter. Now, what convert to entity is doing is it knows how to convert these into ECS versions. So that's really cool. Let's go back to our script. So we've got rotation here. So we go to rot.value. We just have a look at what that is. You can see it's a quaternion with a lowercase q. So it's not the data type that you're used to. But what we could do is we can perform changes to that data and it will be reflected. So we're going to have value equals math.mul, and this is a way to multiply things. There are some data types that you can't just use multiply. You can't just multiply on. You'll have to go through a function, and quaternion is one of them. So if we do rot.value, so what we're doing here is we're taking the rotation and we're getting the quaternion of the rotation, and the quaternion is made up of a float 4, and we're going to times that by quaternion dot rotate y, and then we're going to rotate that by mob.speed times dt. And you'll see the cube's rotating. So we've learned quite a few things there. We've learned about how to make components and systems and how to perform an operation in a system and how to use the entity debugger. So now we've created a system to move things. Let's make it so you can set something to be a player object and the player can move it. So to do that, we're going to need to create a player component. So what I'm going to do is I'm going to go back into Visual Studio, and I'm just going to go to our components. I'm just going to copy this movable component. I'm going to rename it player. So let's go into that and rename this player. Now our player isn't going to have any data on it. It's going to be what we call a tag, and a tag is just a component with no data. And we're just using that player tag to identify what an entity is. So we can add this to our cube and mark it as a player object. Okay, cool. So let's just add this player. You see it just attaches just fine. Now we've got this movable system, but we don't want to have the player input being handled in a movable system. It's more likely that we want to create a separate system to deal with things that the player characters want to do. So instead we're going to create a new system, and again I'm just going to copy this movable system and we're going to call it player system. Open this up, rename this player system. Again, we've got our on update there. Now, so to react to player input, obviously we need to get the input. So I'm going to use a feature in Unity engine. So I'm just going to go to the top here. I'm going to do using Unity. I'm just going to use the old input system. There is a new one out. You could use that for this if you wanted, but I'm just going to use the old one for simplicity. And that's going to be called var x. So it's going to be a float x. Going to look at input, not get this horizontal we're going to look at. So again, this is just like a default Unity but bindings thing, and then we're going to look at the vertical. Call that y. What we want to do is we want to find everything that has both a player component and a movable component. So again, we'll do entities dot for each. There'll be some brackets here, lambda. So in our query, we want to modify the movement. So when we want to modify something, we use the ref keyword. So we'll do ref, like a reference to movable, mov. And we also want to filter for players, but we don't need to modify the player input. So we're just going to use in. And this is just going to give us read-only access to the player. We can't write anything to the player. And there's nothing on the player to begin with to write to, so I'll use it in for now. I'll call this player. So in our movement system, we did .schedule. And if you remember, schedule sets something up to be run as a job. Now, we could still do that here, but if you want to run on the main thread, you can do .run. Now, for very small bits of code, you can easily get away with using .run. And anything that reads from the main thread, you'll need to use .run. But at the moment, we'll just use schedule, as we're not doing anything special here. So we need to modify movement to read the x and y axis of the input. So we'll do mov dot direction equals new float 3, and we'll have x, y. We're moving it. Well, we're moving the y on the z technically, but that's just how we're setting up this project. So let's save that. Now let's go back to Unity. So let's rename this cube player, just so it's a bit more transparent. And we've already got the player authoring script on it. So it's still rotating like before, but now if I move the arrow keys, see how it's moving. We can have a look at the player here. Then we've got this player tag now, player component, and a movable component. So everything's doing exactly what we want it to be doing. If we remove any of these components, if we remove the movable or the player, then we won't be able to control it. It'll just change the speed and it'll just go off. So to make that more clear, if I set that to 0, now if I press the arrow keys, you can see how it's not moving. So again, let's just add the player back onto it. Now you can see how I can control the cube with the arrow keys. One final thing I'm going to show you is to do with this query here. So one thing to bear in mind, when you use the in keyword, anything that reads from a component and doesn't write, you should use the in keyword, and the in keyword variables need to be after ref. But remember what I just said. I said if you need to read from something, you use in. Now our player, we have a look at our player, it's got no data on it. It's just purely a tag component. So we don't need to read from it, but we'd still need to query from it. So we can do that. So let's remove player from our for each query. And before for each, we're going to do .with all. This is just going to filter for entities that have specific components. So we want players. So as you can see, the entity is still running. There's a time and a place for all of the techniques for filtering, and it's important to be aware of ref, in, and the with series of commands on entities. There's other with commands we can use. There's with all, with any, with burst, with none. There's all kinds of filtering we can do here. So that's something to make use of when you can. So what have we learned for this section? Well, we've learned that we can create components using structs inheriting from iComponent data, and we can only have blitzable types in our components, although there are some exceptions that Unity have put in. We can generate an authoring component using the generate authoring component tag. We can convert game objects into entities with convert to entity. And we've learned that systems are just classes that inherit from system.base, and they have functionality like onUpdate. We've also learned we can find specific entities with entities.forEach. We can run entities.forEach multi-threaded with schedule, and we can run entities.forEach on the main thread with run. We can read component data within and write component data with ref. We can use unity.mathematics and unity.transforms data types in ECS, and in fact we kind of have to. And instead of transform, we use translation, and we've got rotation as well to modify our position and rotation and such. In the next lesson, we're going to learn a bit about physics in ECS. In this section, we're going to learn about using Unity physics with ECS. So in this section, we're going to learn about creating physics colliders, rigid bodies, how you would raycast an ECS in a system. We'll also learn a little bit about enemy AIs and how to use random in jobs. Okay, so let's just create a new scene. Let's not worry about that. And I'm going to create a 3D sphere. I'm going to call that player. And I'm going to remove the sphere collider. I'm going to add convert to entity, convert and destroy. I'm going to add the player component and the movable authoring components. I'm going to set the speed to about 4, perhaps. And I'm also going to add something new. So we've got access to a couple of different things with Unity Physics. So I'm going to add a physics shape. Now we removed the collider, but we're going to have a shape. So if I go to sphere, if I set the physics shape type to the sphere, you can see how it works like a normal Unity Physics. Before we go any further, I'm just going to make sure the position is zeroed out. Or we'll look at it again. Now, adding a physics shape makes it like a physics object. Now, we're going to leave all of this kind of default at the moment, but we're also going to add another component. So let's add a physics body. Now, a physics body is essentially a standard rigid body. So let's just add that and we'll see what happens. So as you can see, now it's got a physics body. It starts acting like a standard Unity rigid body would. Let's quickly add a floor. So I'll put this on here. 100, 100. And maybe I'll assign it material. Maybe I'll give our playable a yellow material. Okay, so let's press play now and see what happens. So as you can see, the player is falling through the floor we just made. Now, have a think about why this might be happening. Now, not happening because the floor we just made isn't an entity. So it needs to be an entity to be picked up by the physics world. So let's add convert to entity, and let's press play and see what happens now. Now, as you can see, the ball's staying there. Now, let's pause this again, and we'll have a look in our entity debugger. Now you can see the cube that we made as a floor. Now, you can see it's got this physics collider component, even though, if we stop this, even though we've just got the standard box collider. So you'll remember on the player, we added the physics shape component. So box colliders, like colliders, do get converted by default, but we might need more control over it. So let's remove it. Now let's add a physics shape. You'll see it's a box and should just act as before. So let's run it. And yeah, as you can see, this is working fine. So in a lot of ways, the new Unity Physics works a lot like the old Unity Physics, so it should be familiar. And it's kind of interchangeable if you convert everything to an entity, so that's something to think about. But let's start figuring out how we can start interacting with the physics system. So let's look at some ways our systems can interact with the physics world. So let's go to our movable system. So let's just remove the rotation at the moment. We don't need to be dealing with that. So at the moment we've just got mov and translation. We don't need translation either for what we're doing. For what we're doing, we're going to use the component we looked at very briefly called physics velocity. Now physics velocity will need to be imported. We'll need to import the physics namespace to access it. Let's quickly do that. Unity.physics. So we can kind of remove this code. Don't really need it anymore. So let's create some data to feed into our physics velocity component. I'm going to create a var depth, and that's going to equal of dot direction times of dots. And then we're going to apply that step to the physics velocity. So physvel dot linear step. So we're not using the delta time here, so let's delete that. So it's worth noting that we're only reading from MOV now, so it's more optimal if we mark it as read only. So let's change it to in, not int, in. You can see how we're getting a red line here. Now the reason we're getting this red line is because the order of in and ref needs to be very specific. So ref needs to come first and then in. So let's cut this. And then we'll have in happen after our references, after our refs. And you can see how now the compiler's not complaining anymore. So let's save that. And we'll go to and now what happens if we run it? So it's working like before. Like we can move the player around, but instead of applying directly to the translation, we're going through the physics system. How about we start making a level for Dotsman? So before we make a level, I want to change the snapping. So I'm going to use like a new Unity feature called Quick Search. If you've not used Quick Search before, you might need to import it from the package manager. So it's worth just doing that. It's a very handy new tool from Unity just for quickly finding things on the editor. Okay, now that's important. We can just use Quick Search. I'm going to type in snapping. See, we've got grid and snap settings here. Now I'm just going to change that to 1. So good. So what we'll do is we'll create a maze. So if we create a new 3D cube and we want it to be 0, 0, 0, we'll give it like a blue material. And if I go to my scene, so we've got this cube, and this is going to be like a wall. So we're going to remove this and we're going to add a physics shape. And if you have a look up here, it says the physics shape authoring component on cube 1 is meant for entity conversion, but is not part of a subscene or convert to entity component. So before we do that, we'll need to add a convert to entity component. So I'm quickly going to change this to wall. I'll change our floor to. And before I carry on, we're just going to select our wall. And what we're going to do is we're going to go to our collision filter, and you see it has belongs to everything and collides with everything. Now, we can kind of define what this is, essentially. So, at the moment, everything's undefined. So, we're going to create a player, an enemy, a wall, and a collectible. So these will be our categories. So we'll call our floor and our wall we'll make that belong to nothing and then belong to a wall, and they'll collide with everything. Go to our player. We'll go to our collision filter and we'll set it to nothing to clear it, and set it to player, and again player is going to collide with everything pretty much, so we can just leave that as a default, or we could do or we could kind of just set things as required. So our player will collide with all of the things. Okay, now that's done. We're just gonna kind of make a level using the snapping settings. So what I want you to do is position a wall at 0, 0, 0. And if you hold on to a control and then drag, you can kind of move things in increments of 1. Now for the game we're going to make, it's going to be very important that things are in increments of 1. So kind of copy paste the level together. This might take a little while, so take some time with it. One thing to note is you can kind of use this rect tool. So kind of if you hold on to control, you can kind of drag it out in 1 section increments, and that helps kind of speed out the process. Okay, so I've made a quick basic little map here. Now it's important that for the logic we're making, there's always going to be 1 space here. It's not going to have like 4 open spaces. There's always going to be enough room for 1 rather than enough room for 4, like a traditional arcade maze game. So that's something to bear in mind. But assuming you're done, let's play and see what happens. So you can see how we can't go through things. Like the physics simulation is dealing with collisions quite well. And we can kind of move through things fairly simply. So we've kind of got this basic maze game running already to a very basic level. So what should we do next? Well, I think one of the most important things of these maze games from the past are enemies. So the enemies kind of end up trapping you. So let's think about creating a simple AI for the enemy. Before we go any further, it's probably important to make sure you save your scene. So save as. I'm just going to store this as level 1. So we've cut the video a little bit short there, but if you want to carry on, you can click the link below and purchase the full 6-hour course on udemy.com. Now, I'll do my best to keep the link below updated with the current best price for the course. Now, at time of recording, it's $12.99 if you use the link below. So click that link and you'll really help support me and this channel grow. Thanks for watching and good luck with your future Unity ECS projects.